we're summarizing the stretches and compressions of y equals sine x. So we found in our investigation that the value of a here, the thing that you're multiplying the sine of x by, represents your vertical stretch by a factor of a, if a is bigger than 1 or a is less than -1, like -2 or -3 or -4.5 or something like that. It's a vertical compression. You're pushing it towards the x-axis. If a, that should be in quotes, a is between -1 and +1. So if you had like -0.5 or -3/4 or 1/2 or something like that, that's when you get it compressed. So that's what you need to know about A. If it happens to be negative, it's also reflecting it over the x-axis. So you should notice all of this information really is exactly the same, whoops, up until the blue, is exactly the same as when we are working with our quadratics. So there's really nothing new to learn here other than it looks different in terms of its a different graph than y equals x squared. That value of a will represent the value of the amplitude. So think amplitude starts with a, and it's the a value that's giving you that amplitude value. All right, the other piece that we looked at in the investigation is what happens if we multiply the x by a number. And that compressed your sine curve towards the y-axis by a factor of k. So if your k was bigger than 1, like a 2, I didn't show you what happened with a negative. The negative just does a reflection over the y-axis instead of the x-axis. But if we had like a -3x in that bracket, it would also compress that. There would be 3 cycles happening over 360 degrees. It's a stretch if a is between -1 and +1. So if we had -0.9, or if we had +0.3 or 3/4 or something like that, it will be a stretch. It's going to be that you're not going to get a full cycle happening over 360 degrees. It'll be less than 1. So it affects the period of the graph, and in fact the period is equal to 360 divided by whatever that k value is, ignoring the negative. Okay, so that if you go on with the technical math, you will learn more about that. All right, state the transformations of each function and then sketch the graph. So in the first one, we've got y equals sine x, but that sine x is being multiplied by 2, so that's a vertical stretch by a factor of 2. That means the amplitude will equal 2. And then for our next one here, the 0.5 means we're compressing it by a factor of a half. And then this +1 on the outside, I've just added that in as review from our previous lesson. That's the shift up 1 unit. So in terms of the characteristics here, the vertical compression by a factor of 0.5, that means the amplitude is a half, or 0.5. So amplitude equals 0.5. That translation up 1 unit means the axis of the curve will be at y equals 1. All right, so now with this last one, I've added in all the pieces here. So why don't you try stating what the transformations are and what key characteristics you know. Okay, so if you've tried that, in order, you want to do reflections, then stretches and compressions, then your translations up or down, left or right. All right, so for the first little part here, this negative in front, that's your reflection over the x-axis. The 3 is your vertical stretch by a factor of 2. The 30 gives you the translation 30 degrees to the right. And remember, we're switching the sign. And then the last one, the -1 on the end, is the translation down 1 unit. So that's my order that I'm doing it in, sort of from left to right there. Reflecting over the x-axis doesn't really change our key characteristics. It just changes when we go to graph it. The fact that between the first and second points that are on my axis of the curve, I want to go to a min instead of a max. The vertical stretch by a factor of 3, that's your amplitude, is 3. Amplitude equals 3. Translated 30 degrees to the right doesn't affect your key characteristics so much, but the translation down 1 unit means your axis of the curve will be at y equals 1. All right, so we're going to put these pieces together and graph these 3 functions, and I think I messed up again and might have to do this on the next slide. All right, so I'm starting with a graph of y equals sine x, just sketched in there so that I have it for referral to it. For this first graph, I want to stretch that by a factor of 2 vertically, which means my amplitude becomes a 2 instead of just a 1. My anchor points on my axis of the curve will stay on the axis of the curve. It's just the max is now at positive 2 instead of positive 1, and the min is at negative 2 instead of negative 1. So when I sketch it, it's going to look very similar, except it's just pulling away from the the x-axis, that axis of the curve. All right, so just extending that, bloop, and bloop. All right, so there we are. The next one, I can't see because I've covered it up with my play button here. Hold on a second. Okay, so I just had to pause the video to take a peek at what that said underneath my recording symbols that are up on my screen. All right, my amplitude here is going to be 0.5. It's only going to go up half as much. So if I think of my anchor points still being here, here, and here for now, I only want to go up half and half. All right, but I have to slide each one of those points up 1 full unit. So this gets slid up 1 full unit. My axis of the curve will be at y equals 1. This goes up 1 full unit. This is going to go up 1 full unit. And this goes up 1 full unit. And goes up 1 full unit. So you can see that the curve is going to be a fairly flat one because we're compressing it and just shifting everything up 1 unit. So a half and up 1. And there we are. Okay, so a very flat curve for this one. So this was part B. I should have labeled this one. I'm just going to label them with the parts so that I don't take up too much room here and time. The last one, we got a whole whack of things to do. We need to reflect. We need to give it a stretch vertically by a factor of 3. We need to slide it to the right 30 degrees and move it down 1. So reflect, if I were to reflect the black graph, it's just I'm going to hit my low point. My anchor points are on my axis of the curve here. Hit my low point first instead of the max, and then we're going to go to the, instead of the min, we're at a max. So we have that taken care of for the reflection. I want to stretch that by a factor of 3, so instead of being at -1, I now need to be at -3 here. And instead of being at +1, I want to be at +3 here. So we've done that piece. Now I want to move all of these 30 degrees to the right. So this slides over 30 degrees to the right. And I'm afraid I'm going to lose track of what point is which here. So I'm going to actually switch my color here. Undo that. Let's switch to color, yellow maybe. Go away, go away. I am just losing all my points here. There we are. Okay. I'm struggling with the technology today. Here we go. So I'm moving all of these recent green points to, I think I've erased my one green point that should have been here, which is now here. And this one goes over to here. And then we have to move everything down 1. So let's go with, I don't know what color. Let's just move it down 1. Down 1, down 1, down 1, down 1, and down 1. And now we can draw 1 cycle here of that curve hitting the points that we have finally, there, that was supposed to come down to that one, that we finally have gotten onto our grid there. So hopefully that makes sense. And of course I can extend that curve a bit further. I know that 6 blocks after this spot I should be at my minimum. 1, 2, 3, 4, 5, 6. So my minimum should be down here. I can extend my curve. Whoops. Boy, I'm really struggling now. That's not a good sign. Okay, and likewise I could extend it up here. Okay, so this one is part C. So hopefully that makes sense so far, and then we've got a couple more examples here to do. Okay, let's come up with the equation for this particular graph. So I'm going to look at some points here that I've labeled. I know my max happens when y equals 1 and my min is happening at -3. So that's a difference of 4 units altogether. 4 cut in half would be 2. So my amplitude then has to be 2. And if my amplitude is 2, I'm going to slide 1, 2. That means my axis of the curve will be right here. Okay, so this is 2 units apart. This is 2 units apart, a total distance of 4. So your amplitude, really, if you want to calculate it, you're taking your max. I think we talked about this before in a previous video. You take your max minus your min to get the difference between those two things and then cut it in half. So my max was 1. I'm taking away -3. Divide that by 2. So that's going to give me 1 take away -3 will be 4. 4 divided by 2 is 2. So my amplitude is a 2. Now, the next thing I want to look at is the fact that I've got my axis of the curve at y equals 1. So your equation of your axis is the similar. You can do your max plus your min. You're finding the midpoint, or your min plus your max. Either way works. And divide by 2. You're finding the midpoint, or the average between those two for your axis of the curve. So your min is at -3. We're going to add 1 and divide by 2. -3 plus 1 is -2 divided by 2, which is -1. So this is our A value. We just have to decide if it's positive or negative. And this is the D value on the end, the thing we're going to put on the end of our equation. Now, it looks like there's a horizontal translation as well that we need to worry about here. And this is the beauty of sine curves. There's actually more than one right answer to these things. Now, normally, we start on the axis of the curve and we head up. So it looks like here we're starting on the axis of the curve and we're heading up. And if I look at my scale here, every 2 blocks would be 45. So that makes this spot 135. So it looks like I've taken my spot on the axis of the curve and slid it over 135 degrees here. So I could use a horizontal translation of 135 degrees. So one possible equation for this could be y equals, my amplitude is 2, sine, and I've moved it 135 degrees to the right. And then we've moved everything down 1. So that is one possibility here. However, I could look at this as another possibility. I could go back this way and say, you know what, it looks actually like I've taken my curve and moved it 90 to the left, nope, my bad, undo, there we go. I could think of it as a couple different ways to think of it. So here is my normal, I would normally have this on the origin heading upwards. I could say, you know what, it looks like maybe I've taken it back all the way, I've taken it back here and reflected. Instead of going up, I'm coming down with it. So you could think of this as a 45 to the left and reflection at the same time. So you could make this a -2 sine x plus 45 to move it to the left 45, and then the -1. So if you were to put both of the two curves we have put on our page here in Desmos, it should give you the exact same curve. Okay, so there's multiple right answers for these questions. All right, now we have a chart. We're going to fill in amplitude. The period for all of these, I have not multiplied x by anything in any of these. The periods will be all 360. So I haven't done any horizontal compressions on these, or stretches. So you don't have to worry about the period changing for these ones. All right, fill this chart in to the best of your ability and then check your work. All right, so I filled in my chart here. You should have your amplitudes by the things I've underlined in the blue and written in the blue. Period, as I said, was all 360. The things that are on the end of each of the equations, those represent your axis of your curves. So I've got those in there. Translations I've written, and then your max, remember, comes from your axis of the curve plus your amplitude, and your min is your axis of the curve minus the amplitude.